Okay, so we're going to take a look at another question. This is a University Calculus 2 paper question, Calc 2. This is question 4 from this particular question set. We're told to suppose a 1,000-litre tank contains 150 litres of fresh water at time 0. At that time, salt water solution, brine, concentration 2 grams per litre enters the tank at a rate of 2 litres per minute. The well-mixed solution flows out of the tank at a rate of 1 litre per minute. Which of the following initial value problems correctly model the amount MT of salt in the tank at time t, at least before the tank runs empty and overflows? Okay, so before the tank runs empty and overflows, we don't need to consider the boundaries, which is nice. So let's draw a diagram. We have a tank that looks like this. It has a theoretical maximum capacity of 1,000 litres. It currently contains 150 litres. Water is added, or brine mix, salt water is added up here at a rate of 2 litres per minute, and the concentration of salt is 2 grams per litre. So this is going to be analogous to something like 4 grams per minute. And this is fixed. It's just a fixed 4 grams per minute being added. We also have an outflow down here. The outflow is a perfectly mixed solution. We're assuming that the minute the brine comes in, the whole thing mixes perfectly. So the outflow will be 1 litre per minute, and we don't know the concentration of the outflow, but we do know that the concentration of the outflow will be 1 litre multiplied by the concentration of salt in the tank, which is M of T, divided by the amount of liquid in the tank, which we might call K of T, because it's going to be whatever the percentage salt is, that part of the 1 litre is going to be leaving, right? It's going to be equal proportionality. So we now need to work out how much water is in the tank at each time. Well, there's 150 initially. So K of T, which is our water in this case, is 150 plus 2 litres per unit time, so that's 2T, minus 1 litre per unit time, that's 1T. This is 150 plus T. So this is how much water is in the tank at any given time after time 0. And so now we have the amount of salt coming in is 2 grams per minute. The amount of salt going out is going to be M of T on K of T in terms of grams per minute. So that will be M of T, how many grams there are in the tank, divided by 150 plus T. Now notice this looks like it's in grams per litres, but we multiplied it by 1 litre per minute, so the litres cancelled. So this is actually in terms of grams per minute. Grams per minute. This is the outflow. This is the inflow. So we have our outflow, we have our inflow. dm dt, the rate of change, is going to be the difference between the inflow and the outflow. So this will be the amount coming in minus the amount going out. The amount coming in is 4. The amount going out is mt on 150 plus t. If we rearrange this, we find dm dt is in fact equal to, or dm dt plus m of t on 150 plus t is in fact equal to 4. Of the 4 equations we have here, B is the one that is most similar. B, in fact, is exactly the same as the one we have here. And so B is going to be the correct solution in this case.